Hello and welcome back. We are going to continue deep foundation chapter, design of deep foundation, chapter number 9. So in the previous lesson, we talked about how to obtain the characteristic value or load for the design of ultimate limit load of bearing capacity of pile according to Eurocode 7. Okay. So what we did last time was just the characteristic value. Okay, so today we are going to continue. It was on this point, number 4. We are going to continue to see how we can obtain the design values from the characteristic value, okay, by applying just partial factors. So we will cover from 4 to 6 today, okay. We are not doing example today. It will be from the next lesson, okay. So ultimate limit state. So this is what we did last time. We did already estimate the design force, but we didn't finish estimating the design resistance. We had the characteristic resistance, but we don't have yet the design resistance. Okay. So characteristic resistance, we saw that there are at least 4 methods to estimate them. Okay, estimation from load test, estimation from ground profile, estimation from soil parameter, and even estimation from like observation. So at least 3, not 4. So how can we then obtain the design value from the characteristic value? Okay, so the design compressive resistance of pi, we can obtain it, and this is what we want, RCD, this one. We can obtain it. There are 2 ways. You can consider the pi like a single resistance, like a total resistance, okay? Or you can separate, estimate the base resistance and shaft resistance separately. Then by combining base and shaft, you will obtain the total resistance, okay? So there are 2 possibilities you can do. So you will see that for each possibility you choose, there are some partial factors you can use to estimate the design value. Okay, so the pile resistance, if you treat it as total resistance, then the design pile resistance, you can obtain that design resistance by dividing the characteristic total resistance, okay, by the relevant partial factor. I want this to be very clear for you, okay? In the previous lesson, what we did was just characteristic total resistance, RCK, okay? To obtain the design resistance, we need to divide the characteristic resistance by partial factor, okay? So the partial factors are different. If you treat it as a total resistance, the partial factor you have to use is this one, T, gamma T. So then the formula and the equation for the design resistance will be like this, simply, okay? RCD, design resistance, equal characteristic resistance divided by this partial factor, the total one, total partial factor. This is in case you treat it as total resistance, okay? Now, if you want to separate, as we said, base resistance and shaft resistance, you can do so. In that case, you have also to separate the characteristic resistance. So characteristic base and characteristic shaft resistance, okay? You can see RBK. B means base, RSK, S standing for shaft, okay? You divide these by these two partial factors, the partial factor for the base resistance and the partial factor for the shaft resistance. It will be like this, okay? So in that case, if you want the total design resistance, it is the base one plus the shaft one, okay? You can see that the base one is obtained by dividing the characteristic base resistance divided by the partial factor of the base resistance, okay? B for base, plus here the characteristic shaft resistance divided by this, the partial factor for the shaft resistance. In the previous video, in the previous lesson, we did talk about how to obtain these characteristic resistance. I have to repeat it again, okay? So technically, this is what you have to do to obtain the design value of pile resistance, okay? So now the question is, what are the value of these partial factors? What is the value of these partial factor? You will see that the partial factor will depend on the piling method, okay? If you are dealing with board pile, if you are dealing with driven pile, so each piling method will affect your pile bearing capacity. That is a fact. So how can you consider piling effect in Eurocode? Okay, so now let's go and see what can be the value of these partial factors. Okay, so I will put this here, equation how to obtain the two ways to obtain the design resistance. Okay, so if we go, there is a table in Eurocode that can give us the value of the partial factors, okay, for different piling method, for driven pile, for board pile, for CFA pile, okay, continuous flat auger pile. That means this is the meaning of CFA, okay. So I hope you know what is the meaning of each, this driven pile, board pile, CFA pile. If you don't know, please go and check. I don't remember if I did explain this in the first lesson of this chapter, but go and check. So these are then the value of these partial factors, okay? So you have here the case of driven pi, yeah? Driven pi. So we have here R1, R2, R3, R4. Some people are maybe starting to get confused after seeing this, but don't worry. This R1 to 4 is just to use in different design approaches. As you know, in Eurocode, we have several design approaches, okay? Design approach number 1, design approach number 2, design approach number 3. Design approach number 1 has even 2 combinations, okay? Combination 1, combination 2. So that means these are R1, R2, R3, R4. They are used for different design approaches, okay? So we will see this soon in following slide, which one you have to use in which design approach, okay? But when we say R1, please remember that, because the definition, the meaning of this is very important. R1, if I say R1, it means this column. So in that case, if you are dealing with driven pi for the base, okay,